Okay, next one, open circuit. In the last video clip, we focus on the closed circuit. How about if the circuit is open? What will happen? The charges cannot flow through because this one is disconnected. Okay, the charge cannot flow through. This one we will say that open circuit. And also the switch, we will say that switch off. The light bulb does not glow. Okay, next session, part B, current. Current in Chinese 電流，電嘅流動。Okay， 有帶電嘅嘢嘅流動 current. So, what is the definition of the current? Will be the rate of the flow. Rate of flow. It means that how much charge has passed the cross section of a wire per unit time. It means that you stand here. Okay, you stand here, this cross-sectional area, stand here, and then count it after a certain time, how much charge, okay, pass through this sectional area. For example, 1, 2, 3, 4, 5. For example, 1 hour. Then I will report that within this 1 hour, totally we have 5 charges passing through it. Okay. Then this one we will say that current. 海關都係嘅，你企咗喺呢度做海關，計下1個鐘頭有幾多人行過，呢個就叫人流啦。So in this, we will have this definition, 電流 current. Okay, so you should know that the total charges Q will be depends on number of charge on it, and each charge we have Q, the quantity of it will be Q. This N will be the number of them, N particle. So the total charges will be NQ, okay? And then over the time, Q will be the total charge. This one will be the definition of the current. The unit of it is ampere, capital letter A, ampere. Now look at the first example. Example 1. This. Okay, in this, okay, the question tells you that the current size is 0.1 meter, 0.1 m. This one, A, okay, C1.58 ampere. And also, C will be the coulomb. It means that the total charge. Okay, here the question asks you how long. How long means that the time. The time for this one to die out. Okay, it means that use all the energy already. So what should we do? Try to link up the equation. We want to find out the time, but basically the definition of the current should be Q over T. Just only rearrange these two. Okay, then we can get this. This one will be the total charge. This one will be the current. Current means that in 1 second, totally we will have 0.5 coulomb charge pass through it. Then after the calculation, we know that this time, okay, around 3 hours. Okay, keep going. Next one is the conventional current. What is the meaning of conventional current in Chinese? 慣例電流. It means that in common, we think that the current should be this one. Then this one we will say that conventional current. But in chemistry, we know that the charge can flow through the aqueous state. Okay, usually will be the electron, and also inside the metal, the charge carrier is also electron. It means that electron can flow through the metal, but the positive ion, the positive charge, cannot, because they aim to build up the structure of the metal, so they cannot move. But unfortunately, in scientists, they think that everything should be starting from positive and then ending at negative. It means that in this case, if starting from positive, in the last chapter, positive terminal display positive charge because they are light charges. Repel it. Then the positive charge will move in this way. It means that follow the red line. This red line, we will focus on the charges should be positive. And then come around and then end at negative terminal. This one will be the current we think that around 200 years ago. Okay, but unfortunately, finally we found that positive charge cannot fall through like this because they form the structure. The structure cannot move. Yeah, in order to bring the energy or the charge in the circuit should be focused on the negative one. Okay, and then the actual cases on it will be the electron flow inside the circuit. This one will be the actual current flow. But because this conventional current lasts for 200 years, we cannot change it anymore, because if we change it, everything around this 200 years will change it, or will change it consequently. Okay, then finally we think that this one is true for it. Okay, finally this current we will say that conventional current. Starting from now on, everything should follow it. Okay, in the later session, later chapter. Although we know that this one is wrong, but we keep it. Okay. Then, starting from now on, all the current is conventional current, and also all the current should be starting from positive and ending at negative. The direction of the current should be like that. Okay. Now look at this, and also the current direction should be focused on outside the battery, outside it. Okay, the blue line is the outside case. Outside it should be from positive to negative, but inside it should be from negative to positive. Okay, because what are the difference between them? Outside it means that the energy should be for the other use. For example, the resistor should have energy, okay, consume the energy. Then in this case we will say that outside the current flow through should be starting from positive and ending at negative. But inside the battery we haven't any energy at all, so this one it will gain energy. The EPE gain, electrical potential energy gain, in this will be from negative to positive. Inside the battery will be like that. Okay, now chapter 2. Now look at this, the net movement of the movable charges in it. In aqueous state in chemistry, we will have a positive ion and negative ion. Okay, and then here state the direction of the conventional current. Once again, conventional current, it means that focus on the positive charge, the flow of the positive charge. Then in this case, focus on the flow of the positive charge. It means that focus on positive one will be towards the right hand side. Then your answer will be the right hand side. Okay, in this case will be, of course, left hand side. How about this? Right hand side. This. Okay, you can see that this one is the negative charge to the right hand side, but negative, the opposite one should be positive. If the negative one like that, then positive should be in opposite in direction. So the answer should be left hand side. Question number 2. In this, the total charges will be 300. The time is 10 minutes. Once again, this unit is not second. You should convert it into second. And then ask you what is the current. If you know that the current, of course, using the equation, current should be total charge over time. Okay, put everything in it, then that's all. Okay, charge should be 300, time should be 10 minutes. 10 minutes means that 10 times 60 seconds. Question number 3. The question gives us the current 2.48. Okay, focus on the unit, then you should know that what is it. And also here we have the flow of electrons, the magnitude of the charge of an electron. Okay, one of it will be this one means that lowercase q. And then here we want to find out the number of electrons. It means that n pass through it within 1 minute. It means time, like that. Okay, so try to link up all the symbols together. By definition, current should be the total charge over time. What is the total charge? Should be total number of electrons. For each will be lowercase q. Capital letter N means that the total number, and then T. Okay, everything we know it. Then we can find out the unknown N. Okay, look at this. Unknown N should be IT. Okay, I is this one, T is this. This one is the total charge, and this one will be the charge of each electron. Okay, then the total number is very large number. Okay, part C, current and charge conservation. Okay, now look at this. Current, you know it. What is it? Will be the flow of charge,電流. What's the charge conservation? Conservation means that will not be created or will not be destroyed. We will keep the same amount. Then look at this. If this one is the wall, you stand here. You can see that this wall is a single wall, single direction wall, only one direction. So if you stand here, you can see that the current will be 3A. In 1 second, we have 3 coulomb to pass through this part. And also at the same time, we know that within 1 second, we have 3 coulomb out of this part. Then if you stand on the junction, the current should be the same, 3A. How about the other joint point will be the same, 3A. Okay, so you can see that into the point will be 3A, out of the point will also 3A. And how about the junction? The junction will not be the same. If the current in will be 3A to the junction. But we have 2 ways for it to pass through it. One is up, the other one is down. They may not be the same. If the first move up is 1A, then here in this junction the charge cannot stand here. It will fall. Okay, fall for it. 3A in, 1A out, and then the other one must be 2A out. So you can see that 3 should be 1 plus 2. How about this? We have 2 current come into the junction. 2 in, 1 in, then 3 out. Okay, then this one we will say that charge conservation. Part D, measuring current. In order to measure the current size, other than the calculation, we have the device to do it. And this device we will say that ammeter, or we will use the current sensor. Okay, now try to watch this video.
In this experiment, we will study the currents in series and parallel circuits. Connect 2 identical bulbs in series. Set the applied voltage to a suitable value. Record the readings of the ammeters. Repeat the experiment with different voltages. What do you discover from the readings A1, A2, and A3? Connect the bulbs in parallel. Set the applied voltage to a suitable value. Record the readings of the ammeters. Repeat the experiment with different voltages. What do you discover from the readings A1, A2, and A3?
Okay, in this video, we know that the device can connect in series, 串連. It means that in a one way, link up together in a one way. Then this one we will say that in series. How to make it in series? For example, I can disconnect this wire and then let the other device into it. Left hand side, right hand side, break it down and then link up. Finally, will be like that. Okay, then this one we will say that connected in series. And other than it, we have the safety and precautions if this one is connected in series. Because in order to find out the current, you should have positive and negative terminal. Usually the positive one will be the red in color, because it means that dangerous. And for the negative terminal, usually will be the black one. And also, because this one will measure the current, if the current is too large, it will damage the emitter. So please don't be careful of the size of it. Otherwise, this one we will say that overload the meter. And also, this one is very important in past paper questions. Look at this actual meter reading. Okay, we want to get the reading. Before we get the reading, you should know that how to connect it. Here you can see that maybe 0, 5, and 1. What are they? This one means that the red one, positive, connected to the positive terminal. Negative will be the black one. This one is also black one. But you can find that we should have 1 in and 1 out. But here, 1 in, 2 out. But why? Because you can look at the reading. We have 2 levels, upper one and lower one. Okay, both of them have the 0, but the maximum value will be different. How to look at it? If you've connected to 5, you should find out the reading with 5. It means that the bottom one, you can see that 5. In this case, 5 what? 5A. It means that the maximum value will be 5A. Then this one we will say that full scale reading, 5A. But on the other way, if you disconnect it and then connect it to 1, then what will happen? You will focus on 1 instead of 5. It means that you should focus on the upper part. But upper part is you can't find 1, you only find 10. The maximum value, it means that the full scale diffraction will be 1 meter, 1A. Then it means that 10 is 1A, 4 is 0.4A. 8 means that 0.8A. Okay, you should know that this conversion. Okay. Now chapter 3. Okay, look at this. Chapter 3. Our battery is connected to this network. Okay, this network. What are the emitter reading I1 to I4 in the circuit? Now look at this. Very important part is here, the junction. Okay, and also everything should focus on the positive terminal. You can find that the battery will give out the current. The current size, what is it? Should be 2A. And then this 2A will pass through this resistor, also 2A. Pass through A1 is also 2A, so A1 should be 2A. Pass through it up to the junction is still 2A. But how about this 2? I don't know it. But when this one go back, they will join together, also 2A. Then I4 is 2A. This 2A will come into the battery. Okay, remember that all the charges in the circuit will not be destroyed or will not be created. They will flow through it. But what is the main difference between them will be the energy. The charge come out will have many energy, but when they pass through the whole circuit, it will consume all the energy by the device, for example resistor or light bulb. Then they will go back without any energy, but they can go back. Okay, and how about the junction? The junction, you can see that both of them are identical R. They are no different. So inside this junction, the current will move up and move down with the same amount, because the come in will be 2A. The upper part will be 1A. The lower part will also 1A, because they are the same. Okay, the final answer is this. Okay, question number 2. This one, it seems to be very difficult to see it, but of course not. You just need to focus on the junction, then that's all. And also, what do you want? You want what is I. And in this I, you do not know that in or out. Okay, so what you do? You try to find out the junction. Okay, the junction. In this junction, the information is many on it. Then you should focus on it. Okay, then among all the junction, you can see that this one and this one can give you many information. Look at this: 3 in, 2 in. Then this one must be 5 out. Okay, how about this? 1 out, 2 out. So this one should be 3 in. And here in this junction, 5 in, 3 out. So this one should be 2 out. This one for this junction will be 2 in, 4 in, then 6 out. For this junction, 6 in, 2 in, 8 out. That's all. Okay, question number 3. Okay, number 3. The light bulb is connected to a battery like that. Okay, which of the following best show the current flow? The current flow should be starting from positive like that. Okay, all of them should be the same, and then come out to the negative. This one haven't, so this one is wrong. This one is not the same direction, wrong. This one is okay. But you can see that the current size will not be the same. The current should keep the same. Okay, there's no change in the total charge inside the circuit. The main difference will be the energy only, the electrical potential energy only. Okay, question number 4. Mary wants to measure the current passes through the resistor in the following circuits. Are the emitter correctly connected? Okay, look at this. Focus on the battery. We have the positive, the current pass through the emitter, connected in series, okay, and then go to here, pass through the resistor, and then come back to the negative one. This part is okay. How about the light bulb? Also across it should be the same. Okay, but the answer is wrong. How to know that? Because go through this one. Mary wants to measure the resistor. Okay, the current pass through the resistor. But if you do it like this, then what will happen? It will measure the total current generated by the battery, not the resistor. Okay, because this current reading will include the resistor and the light bulb together. Okay, because all the current given out by the battery will be the current passes through resistor and light bulb. Okay, but the question wants to pass through the resistor only. Okay, so this one is wrong. And then how about this? Also wrong, because the polarity is wrong. Positive should be link up to the positive, so this one is wrong. Okay, but if this part is okay, I change it into positive and negative, then you can see that the current pass through the emitter and the emitter, the current pass through the resistor on the same path. It means that in series. Okay, then this part is okay.